Welcome back, everyone, to another deep dive. Today, we're going on a journey into the world of really, really big data.
That's right.
We're going to explore how LinkedIn scaled its Hadoop distributed file system, HDFS,
Mm,
to handle just massive amounts of data.
yeah,
Now, I know what you might be thinking, a technical document
right.
sounds a little dry,
Yeah.
but trust me, we've gone through it and we've pulled out all the exciting stuff, the real kind of mind-blowing moments that'll change how you think about data.
And just to give you a taste of the scale, think about this. A file system with over 1.6 billion objects.
Wow, okay. My mind's already blown. But before we get lost in the billions, can we take a step back for a second?
Sure.
Why is Hadoop so important to companies like LinkedIn? Like, what's the big deal?
Well, think of Hadoop as the engine that drives LinkedIn's ability to understand its users. It's the foundation for all their analytics. Everything from, figuring out user behavior to those people you may know suggestions.
Oh, right, okay.
Without Hadoop, LinkedIn would be drowning in data. It wouldn't be able to make sense of it.
So it's like the brains of the operation, taking all that information and actually, making it mean something.
Exactly. And to give you an idea of how much information, we're talking 500 petabytes of data.
Okay, now you've lost me. What is a petabyte?
So if you had a laptop, right, with 1 terabyte of storage,
Okay.
you would need 500,000 of them to equal the data in LinkedIn's Hadoop cluster.
500,000 laptops. That's crazy.
Mhm.
And they're managing all that with 1.6 billion whatchamacallits.
Namespace objects, think of them like folders, files, all the building blocks organizing the data.
Ah, okay. So we've got this massive amount of data, this crazy complex system to manage it all. What could possibly go wrong?
Well, with any system that big, the biggest challenge is keeping it running smoothly. In the early days of Hadoop, a single point of failure could take the entire system down.
A single point of failure? What does that even mean?
So imagine the name node. It's basically the master directory for the whole Hadoop system. Okay. Now imagine it fails. It'd be like losing the library's card catalog. Chaos.
Yikes.
All that data would be inaccessible.
So a total disaster. So how did LinkedIn solve that?
They implemented something called high availability, or HA.
Okay.
Think of it like a backup generator for your house.
Right.
If the power goes out, the backup kicks in.
Okay, makes sense. So 2 name nodes instead of 1.
Exactly. Always ready to take over.
But how do they keep those 2 in sync? What if they get out of whack?
That's where the Quorum Journal Manager comes in. Or QJM. It's like a really, really reliable record keeper, making sure both name nodes have the exact same information.
So like a super organized note-taking system, always up to date.
You got it. So even if one name node crashes, the other one is ready to go.
That's pretty impressive. But what happens when they need to upgrade the system? That can't be easy with all that data constantly moving around.
It's a huge challenge. But LinkedIn actually figured out how to do it without any downtime at all. They use something called rolling upgrades. They can update parts of the system one by one while everything else keeps running.
So they never have to shut the whole thing down.
Nope.
That's incredible. But let's zoom in for a second. What's happening on those name node servers? How do they handle all that data?
Well, each name node runs on Java.
Okay.
But we're not talking your regular cup of coffee here. We're talking a Java heap. It's basically the memory space where Java stores and processes data.
Okay.
And get this, LinkedIn's name node has a 380 gigabyte Java heap.
380 gigabytes.
Yeah, it's a massive amount of memory.
I can't even imagine. What does that even look like?
Think of a beach covered in sand. Now try to keep track of every single grain of sand. That's kind of what it's like.
Wow, that's a pretty wild picture. So how do they manage something that big? It sounds like a recipe for disaster.
That's where Java tuning comes in.
Okay.
It's complicated, but it's kind of like organizing a really messy closet. You have to divide things up, put them in different sections, and in this case, those sections are called generations. You've got young generations for new data and old generations for, well, older data. By carefully managing these generations, they can avoid these things called full garbage collections.
Okay, so they're organizing their data.
Yeah.
But what are these garbage collections you're talking about?
Well, let's just say they're not a good thing. It's like your computer suddenly freezing for minutes at a time.
Oh, yeah, that's not good.
Especially when you're dealing with a system as huge as LinkedIn's. But they have another trick up their sleeve, too, something called non-fair locking.
Non-fair locking. That sounds a little, well, unfair.
I know, right? But it actually improves performance.
Yeah.
Think of it like a playground with a swing set.
Okay.
Usually kids line up and take turns. It's fair, but it takes time. But what if there were a lot more kids who wanted to just watch than swing?
Right.
With non-fair locking, the watchers could go ahead, enjoy the show, and the swingers, who take longer, would wait their turn.
So it's all about letting the faster processes go first.
Exactly. It keeps things moving smoothly.
So in this case, the watchers are those requests to read data, which are quick, and the swingers are the write requests, which take more time.
You got it. And to make sure all this tuning is actually working, LinkedIn uses this open source benchmarking tool called Dynamometer.
So like a stress test for their Hadoop cluster.
Exactly.
They can see how it performs under pressure.
Yep. And they're constantly testing things, trying to find the best ways to keep it running smoothly.
That makes sense. We've talked a lot about those big files, but what about the small ones? Don't they cause problems too?
You bring up a great point. Small files can be a big headache in a large Hadoop cluster.
How so?
Well, think of it like a library with a catalog bigger than all the books it holds.
Okay.
The information about the files, the metadata, takes up more space than the actual data itself.
Ah, I see.
And one of the biggest culprits is this directory called system.
Yeah.
It's full of these tiny configuration and log files, millions of them.
So even though each one is small, together they take up a ton of space.
Exactly. And that's what LinkedIn was facing. They had to find a clever solution. So they decided to create a separate cluster just for these small files.
A separate cluster, like a mini Hadoop just for small files.
Exactly.
Interesting.
It's like having a whole separate wing of the library just for those tiny index cards.
Right.
Keeps them out of the main system.
That makes sense. But how did they move all those millions of files? That couldn't have been easy.
You're right, it was tricky. They first tried using this tool called distp. It's designed to copy files between clusters,
What?
but it was like trying to move a mountain of sand one grain at a time.
It's way too slow.
Way too slow. So they had to get creative.
What did they do?
They built this custom file system driver called failover-fs.
Failover-fs.
So it's like a traffic director for files.
Okay.
It seamlessly redirects new logs to the satellite cluster.
So no one even notices.
Exactly. And gradually they moved the existing small files over as well without disrupting the main Hadoop system.
Clever. But I'm guessing it wasn't all smooth sailing.
Well, there were a few bumps along the way.
Like what?
They ran into this issue with massive block reports coming from the data nodes on the satellite cluster.
Block reports?
It's basically the data nodes reporting where the blocks of data are stored.
Right.
But these reports were huge. It was like those tiny files were shouting their location from the rooftops.
Overwhelming the name node.
Exactly.
So their solution to one problem created a new problem.
Pretty much. But they found a fix for that too.
What did they do?
They came up with something called virtual volumes.
Virtual volumes.
They basically divided the storage on each date node into smaller virtual chunks.
So instead of one big shout, it was more like a bunch of smaller, quieter ones.
Precisely.
That's pretty ingenious. So they tamed those pesky small files.
They did, and it made the whole Hadoop cluster run much smoother.
That's great. But I'm thinking, with all that data constantly being used and analyzed, how do they keep up with demand? Even with a superpowered name node, wouldn't things get bogged down eventually?
You're right, even the most powerful name node has its limits. As the cluster grew, they realized they needed to spread out the work, especially for read requests.
So what did they do? Just buy more servers?
Well, hardware helps, but they came up with a smarter solution.
Oh.
Remember those standby name nodes we talked about?
The ones with the synced up node?
Yeah.
Got it.
Well, they realized they could put those standby name nodes to work handling read requests.
Ah, so they weren't just sitting around idle anymore.
Exactly.
That's smart.
They're now called observer nodes, and it's a key part of modern Hadoop systems.
That's a great way to make use of those backup systems.
Right.
But wouldn't there be a risk of getting outdated information from the observer nodes?
That's a valid concern. You don't want to end up with stale data.
Right. That could cause all sorts of problems.
Exactly. So they implemented several techniques to address this.
Okay.
One of them is called fast path journal tailing.
Fast path journal tailing. What is that?
It's like getting a live feed of updates. Think of it like a news ticker constantly streaming the latest information.
Oh, so the observer nodes are always getting the freshest data?
Exactly. And to be extra sure, they also use something called last seen stated.
Last seen state. Okay. I'm taking notes.
Think of it as a timestamp that verifies you're seeing the most up-to-date version of the file.
Like a last updated deed on a website.
Exactly.
Yeah.
And there's even more.
Oh.
They use something called the msync function,
Okay.
which ensures any changes are immediately reflected in the observer nodes.
So no lag time?
Nope. And then there's automatic client state synchronization. That makes sure all users are accessing the same up-to-date info.
No matter which name node they're connected to.
Exactly. It's a whole system working together to prevent stale reads.
Wow, sounds like they've really thought of everything.
They have. They take data integrity very seriously.
Which is good, because it sounds like things could go wrong pretty easily if they didn't.
Absolutely. But let's shift gears a bit. We've talked about scale and performance, but what about security?
Yes. It's not just about storing data, it's about protecting it too, right?
You got it. And LinkedIn takes security very seriously, especially with regulations like GDPR and CCPA.
Right. So how do they approach security?
They have a multi-layered approach,
Oh.
focusing on 3 key areas: port-based selective wire encryption, encryption at rest, and a system called wormhole.
Okay, break those down for me. Starting with port-based selective wire encryption. What is that?
It's like a secret handshake for secure communication.
Okay.
They encrypt data coming from outside their data centers, but keep internal traffic unencrypted for better performance.
So strategic encryption.
Exactly. Protects sensitive data without sacrificing speed.
Makes sense. And what about encryption at rest?
Think of it like a vault.
Oh.
Even when no one's accessing the data, it's still locked up tight.
So even if someone breaks in, they can't read the data.
Precisely. Now, wormhole is a bit different.
Wormhole. Does it involve interdimensional travel?
Not quite. It's their system for transferring data from HDFS to other systems.
So like a data pipeline.
Exactly.
Moving data to where it needs to go.
Yep. And they use these smaller clusters called Dropboxes in each data center.
Dropboxes.
Think of them like regional distribution centers. They minimize the amount of data that has to travel between data centers.
So it's all about efficiency.
Exactly.
Yeah.
Getting the right data to the right place as quickly as possible.
It seems like efficiency is a theme in everything LinkedIn does with Hadoop.
It is.
They're always finding ways to optimize and streamline.
They're constantly innovating, finding new solutions to these huge data challenges.
Well, it's clear that LinkedIn has put a lot of thought into making their Hadoop cluster not only powerful, but also secure and efficient.
They have.
They've really thought of everything.
And it's not just about keeping their own data safe. They're also active in the open source community, sharing their knowledge and contributing back to Hadoop.
That's great. It shows they're committed to pushing the field forward.
Absolutely. But with all this talk of scale and security, I can't help but wonder what's next for data management.
What do you think? What are some of the trends we might see?
Well, one thing is for sure, data is only going to get bigger and more complex.
Right.
So companies are going to need new ways to manage it all.
Yeah.
We might even see a move toward these decentralized systems.
Decentralized data systems.
Yeah.
What's that?
Instead of keeping everything in one giant data center, they spread it out across multiple locations. It's like diversifying your portfolio, right?
Right. Less risk.
So if one part of the system goes down, the rest can keep running.
Exactly. Plus, it could be good for data privacy, too,
How so?
by keeping data closer to the people who generated it.
Oh, I see.
There's also this whole other thing brewing. Quantum computing. Quantum computing. Isn't that still, like, science fiction?
It kind of is, but it's getting closer every day.
So what's the big deal with quantum computing?
Well, these quantum computers can do calculations that regular computers just can't.
Right.
That could totally change data management. Imagine solving problems that are impossible today.
Unlocking secrets hidden in the data.
Exactly.
That's wild.
It's a pretty exciting time for data, that's for sure.
It really is. It's been amazing exploring LinkedIn's Hadoop journey.
Yeah, it has.
We've seen incredible scale, intricate Java tuning, even satellite clusters.
We talked about high availability, efficient data transfers, and all those security measures.
It's clear they've put a ton of thought into this.
Absolutely.
And I think the biggest takeaway is this. Data management isn't just about the tech.
Right.
It's about solving real problems.
It's about constantly adapting and pushing the limits.
If you want to dive deeper into LinkedIn's approach, check out the show notes for links to the full source material.
Always more to learn.
Thanks for joining us on this deep dive. And until next time, keep exploring, keep learning, and keep digging into the amazing world of data.